I'm going to talk about the basic mod operator today. Just what happens when we take one number, mod another number. We're not even going to throw incongruence in there yet. We'll get to that very soon. Let's just get our setup first. We're going to just think of this situation where we have two numbers. So m is the modulus, and this is always a positive integer in this basic scenario, but really just in general, m is always positive. And then we're also going to need another number, d, and d is going to be, in this case, we're going to just have d be bigger than or equal to 0. So d is a non-negative integer. So what we want to do is just understand what this means. D mod m. So d mod m can be written this way. It can be written with parentheses. I generally like the parentheses. It just contains the mod a little bit better, helps you visually break it up, but that's all it does, is a visual thing. And also, we're not going to use this in general, but if you do any sort of computer programming, the mod operator often is a percent sign, so d percent m. This is just equal to the remainder when you divide d by m. So we're just doing division with positive numbers right now. We'll take something like 21 mod 5. So if you take 21 and you divide it by 5, 5 will go on 4 times, you'll have a remainder of 1 left over. It's 20 plus 1. So 21 mod 5 is equal to 1. And again, we could have written it this way, 21 mod 5 without parentheses. 23 mod 5 is 3, and 20 mod 5 is 0. So whenever it just goes in, without any remainder, the mod just evaluates to 0. So the goal, at least initially, is to get the smallest positive integer for your answer. Obviously, it has to be smaller than what you're modding by. And order matters here. So if I did, let's say 5 mod 2, well, 5 mod 2 is 1. But if I do 2 mod 5, that's 2. So we always have to think of this number here as what we're dividing by. And in the case of 2, if we try to divide 2 by 5, it doesn't go in at all. So our remainder just is 2. So if you have a larger number here, it's not going to go into this number at all. And the remainder is just your initial number. Another example, if I flipped around this one and did 5 mod 23, again, 23 doesn't go into 5 at all, so we leave the remainder of 5. And then if you have a 0 here, then any number goes into 0. So I could do 0 mod 127, and that's 0, really 0 mod anything, any m will be 0. This is our basic setup when we have positive integers. We need to be able to work with negative integers here. On the left-hand side, again, modulus will always be positive. Before we look at how to kind of deal with the negative integer situation, let's just think a little bit more about this one, 23 mod 5. 23 mod 5. Obviously, we know it's 3. One way to think about it is the way I've presented it. We divide and we look at what the remainder is. Another way to think about this is to just subtract 5 repeatedly from 23 until you get down to a remainder. Because division you can kind of think of as repeated subtraction. We're going to take this and I'm going to do repeated subtraction. 23 minus 5 is 18. 18 minus 5 is 13. 13 minus 5 is 8. 8 minus 5 is 3. So repeated subtraction is giving us a remainder of 3 as well. So the reason I'm presenting it this way is because when you start working with negative numbers, it starts to get a little weirder to think about the remainder. Let's consider the case where D is allowed to be negative, the number over on the left-hand side. So case 2, M is still a positive integer, always, always, for modular arithmetic. And D is now allowed to be negative. Before we restricted it just to bigger than or equal to 0. So if I wanted to do something like negative 23 mod 5, you might be tempted to say 3 because you do the division of 23 and 5, you still get a remainder of 3. You might get tempted to say negative 3, which is actually a better, closer to the correct answer, just because you're finding the remainder and leaving it negative. But the easiest way to think about this at first is just to, instead of doing repeated subtraction from our number, let's just repeatedly add 5 until we get a number that's positive. If I do negative 23 plus 5, oh my gosh, why is this is minus 18 plus 5 is minus 13. Minus 13 plus 5 is minus 8. And minus 8 plus 5 is minus 3. That's why I said, that answer is closer. And then minus 3 plus 5 is 2. And in the case of negative 23 mod 5, the answer is actually 2. And of course, repeatedly adding 5 would get really old, especially if you have a bigger number. But you want to think of it that way, at least for now. But you don't have to write out, a bunch of additions just to figure that out. So say we had something like negative, 47 mod 5. Right, you might look at this and say, okay, well, sure, I could just keep adding 5 and that would get really old really fast. You might think of some shortcuts already, which is great. It means you're getting it. But you could also think like, okay, well, I know that 40 is just a bunch of 5s. So instead of adding 5 over and over, I'll add 40 and then get negative 7. And add 5 again if you desire, and you get negative 2. And add 5 again, and you get 3. So really we're just adding 5s or multiples of 5s until we get the smallest positive number. Of course, I said you could have taken some shortcuts if you're seeing it already. I mean, we know that 50 is a multiple of 5, so potentially you might have just said, okay, well, negative 47 plus 50 is 3. And then that's going to be your answer because 3 is going to be your lowest positive number. If it goes in evenly, your remainder is still 0, whether it's positive or negative. So if I have negative 20 mod 5, then that still equals 0. We don't have to think about anything other than saying it goes in evenly. There's no remainder still. I think this is a good place to stop, but to get a better feel for this, lots of shortcuts, and a fuller definition of modular arithmetic, I would recommend that you watch the next videos on congruence mod and whatever else I end up recording on this topic.